Hello guys, this is the chapter of electrochemistry. Now I am going to start to explain you. Now what is electrochemistry? Now as you can see in our screen, the branch of the science which deals with the relationship between electrical and chemical energy and their interconversion is called electrochemistry. मतलब साइंस की वो ब्रांच जिसमें इलेक्ट्रिकल और केमिकल एनर्जी के बीच में रिलेशनशिप होता है, यानी जब हम किसी से इलेक्ट्रिसिटी को पास करते हैं तो वहाँ पे केमिकल चेंजेस होते हैं, या जब केमिकल चेंजेस होते हैं तो हमको इलेक्ट्रिक करंट मिलता है. ठीक है, तो जैसे मान लो कोई टॉर्च है, उसमें सेल लगे होते हैं, तो सेल में अंदर केमिकल्स होते हैं. तो जब हम टॉर्च जलाते हैं तो उन केमिकल सेल्स की वजह से हमको करंट मिलता है. The electrochemistry is that branch which deals with the electrical and chemical energy. So now the chemical changes which involve the flow of electric current, यानी ऐसे chemical changes हो जिसकी वजह से करंट का फ्लो होने लगे, उसे हम electrochemical changes कहते हैं. So now what is electrochemistry? It is that branch of science in which we study the relationship between electrical and chemical energy. Now the devices in which electrolysis is carried out by using electricity, or the devices in which the conversion of electrical energy into chemical energy is called electrolytic cell. Now generally there is a question asked, what is electrolytic cell, what is galvanic cell, what is voltaic cell, etc. Now firstly, what is electrolytic cell? So the vessel or the device in which electrolysis is carried out by using electricity, that means in which there is a conversion of electrical energy into chemical energy. That means we pass the electrical energy and it converts into the chemical energy. That means electricity is get converted into chemical energy, and that device is termed as electrolytic cell. Now what is galvanic cell? It is a device in which redox reaction is used to convert the chemical energy to electric energy. That means in galvanic cell, reverse has happened. In galvanic cell, we get electrical energy by the chemical energy. And in electrolytic cell, we get chemical energy using the electrical energy. Okay. The other differences between the two cells include that in the electrolytic cell, anode is positive electrode, while cathode is negative. In the electrolytic cell, anode, A for anode, it is always positive and cathode is negative. But in the galvanic cell, it is opposite. Anode is negative. Okay, and cathode is positive. Okay, so anode, AN, anode is negative. Clear? So that means electrolytic cell and galvanic cell, their functioning is totally reverse of each other. So now I am again explaining you chemical energy changes to electrical in the galvanic, that is voltaic cell. Okay, and in electrolysis, electrical energy changes into chemical. This is E for electrolysis, that is electrical changes into chemical. Now, second point, in electrolytic cell, ions are discharged at both the electrodes, while in galvanic cell, ions are discharged only at cathodes. At anode, we don't have any ions. Now, we can simply see this figure. There's this plus sign, that is anode, this is cathode. Okay, now these are connected with each other. Here, in the galvanic cell, generally there is a type of a partition in between them. Okay, clear? Now this is connected with battery. Now comes to the next topic. Now we understand what is the difference between the galvanic and the electrolytic cell. And what are electrolytic cell? These are the devices by which we get the chemical energy. There is an interconversions of chemical energy into electrical energy. Now what are electrolytes? There is a difference between electrolytic cell, galvanic cell and electrolytes. All these are different with each other. Now what are electrolytes? These are the substances which allow electricity to pass through them in their molten states. That is in the form of their aqueous solution. In dry state, we doesn't pass any electricity in them. That means, for example, if we dissolve sodium chloride in the water, this is the aqueous solution, and it conducts electricity. So that's why that becomes an electrolyte. And generally, water dissolved, sodium chloride dissolved in water is generally known as brine solution. So all the electrolytes, that means salts, are dissolved in water, then when they are in molten states, when they are in aqueous, they form aqueous solution, they becomes electrolyte and they allow electricity to pass through them. So from here, a substance will dissociate into its ion when dissolved in a polar solvent like water, they are electrolytes. That any substance which dissociate into ions when it dissolved in the solvents like water. That means when we dissolve sodium chloride into the water, it dissociates into the ion sodium plus chlorine. So now it becomes an electrolyte. Now what is electrolytic conduction? So these are the different definitions. You must remember them. You must learn them. Okay. Now next one, electrolytic conduction. Now all the definitions are also given here. You can just pause the video and or you can take the screenshot and you can write these definitions and learn by heart. Now what is electrolytic conduction? The conduction of electricity because of ions. So when we get electricity due to ions, then this is known as electrolytic conduction. Now conductivity of electrolytic solution depends upon the nature of electrolyte, size of the ions produced, that means sizes are big or small. Nature of the solvent, that means if we dissolve sodium chloride in water, it has different effect. When if we dissolve sodium chloride in, for example, in carbon tetrachloride, it has different effects. So what is the nature of the solvent in which we dissolve these solutes? Now concentration of electrolytes and temperature. So all these factors on which conductivity of electrolytic solution depends. That means how much current we get from that electrolyte. The factors on which it depends. These are 4 and 5 factors. Now next one, acid, bases and their salt. All are the examples of electrolytes. Anything can be an electrolyte. An electrolyte can be strong, can be weak, and strength of electrolyte depends upon ability to dissociate. How much it dissociates into the ions. Whether it dissociates completely, whether it dissociates partially. It decides whether that electrolyte is the strong electrolyte or weak electrolyte. Now for example, sodium chloride. It dissociates completely. Hydrogen chloride, H plus Cl, K, potassium chloride, K plus Cl. So they have ability to dissociate completely and almost completely. So all the electrolytes, all the acid, bases and salts which completely dissociate, they are termed as the strong electrolytes. And all the electrolytes on the other hand which are very less dissociated as compared to, so these are known as weak electrolytes. So that means whether the electrolyte is strong or weak, it depends upon their dissociation in the polar solvents. Now next one, what is difference between conductance and conductivity of electrolytic solution? Now we are going to explain you. The power of an electrolyte to conduct electric current is called conductance. Now we have an electrolyte. What is electrolyte? When we dissolve any acid, base and salt in the water or polar solvent, we get the electrolyte. Okay. Now every electrolyte has a power, has a strength. So the strength of electrolyte to conduct electric current, how much electric current it gives us, this is known as conductance. And conductance and conductivity both are the same terms. There is no difference. Just like metallic conductors, electrolytic solutions, they also obey the Ohm law. And so when they obey Ohm law, that means the current flowing through them is directly proportional to the potential difference. Okay. So again we get the same thing. Clear? We all know about the Ohm's law. Now we also have a term from the Ohm's law, resistance. Now there is a relationship between conductance and resistance. They are reciprocal to each other. Now we know that the unit of resistance is ohm. So unit of conductance is ohm per ohm. We can also say that the unit of conductance is mho. And we denoted it by mho ohm. In a SI system, its unit is Siemens. Now clear? Now next one. So here its unit is Siemens. Unit of conductance in SI system is Siemens. Remember it. Okay. Now resistance of a conductor is directly proportional to the length. We know the formula of resistance, rho L by A. Okay. Now where rho is a proportionality constant which is known as specific resistance or resistivity. This rho is also known as resistivity. Now just go ahead. Now the factor L by A, this is resistance, this is resistivity, R is resistance, rho is resistivity, and L by A, That is length of conductor over area. Oh God. So now we have to study from here molar conductivity. The conducting power of all the ions produced by dissolving 1 gram mole of electrolyte in a solution. When we dissolve 1 gram mole of an electrolyte in any solution, this is known as molar conductivity. That means when we dissolve 1 gram mole of any electrolyte in the solution, the power by which it produces the ions is known as molar conductivity. It is generally denoted by this lambda and m. Okay. Now formula there is this kappa into 1000 by, now here it is molar conductivity, so we write m. We divide by molar conductivity. And kappa is what? A specific conductance. Where m is the molarity, concentration and molarity of the solution. Now what is its unit? Its unit of kappa is Siemens and unit of molarity is per mole. Okay, mole per liter, so per mole. So its unit becomes Siemens centimeter square per mole. Okay, now comes to the next topic of equivalent conductivity. Now in equivalent conductivity, you can see over here the conducting power of all the ions produced by dissolving 1 gram equivalent of the electrolyte in the solution. That means when we dissolve 1 gram equivalent in the molar conductivity, we dissolve 1 gram mole of electrolyte. In equivalent conductivity, we dissolve 1 gram equivalent of electrolyte in the solution. This is known as equivalent conductivity. This is denoted by lambda EQ, okay, or this symbol also, reverse of V. It is related with a specific conductance as kappa into 1000 over conductivity. That means here we write, here we write the normality N, concentration in normality, concentration of solution in per liter, that is normality. Now see the numerical. For example, we have a numerical like this. The resistance of DC normal solution of a salt occupying a volume between two platinum electrodes 1.80 centimeter apart and 5.4 centimeter square in area, found to be 50 ohm. Now we have to collect the data. DC normal solution, that means normality is 1 by 10 and the distance between two electrodes is 1.8, that means this is L, and 5.4 centimeter square, this is the area. Okay, and 50 ohm is the resistance. Now if we have to find the equivalent conductance, we can see easily we have this formula. That means conductance into 1000 and normality. Clear? So from here we have to find conductance, which is equal to 1 by R. Now value of R is 50, so we put over here and we get 0.02. Now we have to also find the value of cell constant, so which is equal to 1.80 upon 5.4, simply. Now normality is DC normal, that is 1 by 10, that is 0.1. So now this is the formula for equivalent conductivity. So we put everything. So this is the formula 1000 into conductance into cell constant into concentration of normality. So we put everything and we get the answer. Now unit here you can easily see Siemens centimeter square, and as it is equivalent conductivity, so we write per equivalent. If that is molar conductivity, then we write mole per mole. Okay. Now next topic called Roche law. This is very important law. Please learn it by heart. One question or either theory of the Roche law is generally asked in your examinations. Now what is Roche law? According to Roche law, the molar conductivity of an electrolyte at infinite dilution is the sum of molar conductivity of ions produced by electrolyte at infinite solution. Listen. In other words, we can say that sum of molar conductivity of cation and anion at infinite dilution. That means if we have any solution which was too diluted, then if we find the sum of cations and anions which are present in that solution, that gives us molar conductivity of that total electrolytes. So Roche's law represented mu C and mu A, that means for cation and for anion, and infinity, that means for infinite dilution. So total mu you can also write as kappa, that sign lambda. So molar conductivity is number of cations, that is plus, number of anions, that is minus. You have to multiply both. This is the sum of them. Clear? At infinite dilution, where n1, n plus and n minus are the number of cations and the number of anions. n1, n plus is represented by cations and n minus is represented to anions. Now you can see an example for the Kulroff's law. For example, we have a electrolyte, acetic acid. Now when it dissociates into CH3CO minus and H plus protons. Now we can write it as, for example, we have along with sodium acetate. Now sodium is this ion get dissociated by sodium ions, and this is by minus ion. So Kulroff's law, this is the sum of both cations and anions. Similarly, if we have HCl, now we can write it as H plus Cl minus. If we have another electrolyte Na plus Cl, that we have write Na plus Cl. So from the Kulroff's law, it tells about that total molar conductivity is the sum of both the ions which are dissociated. Now if we have to find the degree of dissociation for the weak electrolytes, we use this formula. Okay, for the cation over infinite dilution. That means alpha is the degree of dissociation, molar conductance at any concentration, and molar conductance at infinite dilution. That means when we make the solution infinitely dilute. Okay, and now Kulroff's law is also used to, that means this is the application of Kulroff's law. That means Kulroff's law is used to find the degree of dissociation. How much the electrolyte get dissociated in the solution. And Kulroff's law is also used in determining the ionization constant of weak electrolyte. It is also used in determining the solubility of soluble salt, how much that salt is dissolved in that liquid. Now we have a numerical. 0.1 molarity H2SO4 is diluted in this. It has molarity 0.1 and it was diluted to 0.001. That means it makes more diluted. Now we have to find its molar conductance. Okay. Now we have the formula kappa into 1000 over n. Clear? Now initial and final. So when we divide it, then kappa and 1000 remains same in both the cases, initial and final. They will cut down. So ultimately we get, this is inverse of m. So here f, so it is final position. And it is initial, so here we get the initial position. So now we dilute it to 0.01. And we have in the starting 0.1. So we have to divide both of them. Clear? So in this way we get this relation, and when we solve 1 by 10. So from here final one is 10 times the molar conductivity. Okay. So from here it is option number A, 10 times. Okay. So now next topic we have electrolysis, and I will discuss in the later section. Now we learn what is electrolysis in this lecture. Electrolysis is a process in which electric current is used to bring about a chemical change. What is electrolysis? In which we send the electric current and it brings the chemical change. Now it is generally done in the electrolytic cell. So in electrolysis, electric current is used to bring a non-spontaneous chemical reactions. So this is overall. Now for example, we have an NaCl. When electric current passes through it, it dissociates into two parts, Na plus Cl minus. Now Na, it has positive ion, so it goes to cathode. Cl, it has negative ion, so it goes to anode. Okay. So now what happens at anode? Fluoride goes to here, it gains electron and becomes fluorine gas. Okay. So simply these are the reactions which held at the different anode and cathode, different electrodes of the electrolysis. Okay. Now comes to the next point. For example, we learned what happens during the electrolysis of sodium chloride. Now in case of sodium chloride, water is also present along with sodium and chlorine, because dry NaCl does not conduct electricity. So we have to dissolve sodium chloride into the water, and then we pass the electricity. So at anode, chlorine and water both are collected. Both the reactions will help. Now chlorine has chlorine plus 2 electron. It has electrode potential of 1.36. In water, it has electrode potential of 1.23. Now, if the solution of NaCl is concentrated, then chlorine is the main product, because then amount of chlorine is become more, and also it has less electrode potential, minus. So chlorine is the main product. However, if it is dilute, the product of oxygen, because when we see the reaction of chlorine, we get here oxygen. Then the product of oxygen we get because of over voltage. That means when the solution is diluted, okay, then we get oxygen at anode. But if the solution is concentrated, we get chlorine at anode. Okay. Now at the cathode, what happens? sodium, okay, it has electrode potential, this one. Now here water, here it goes hydrogen as cathode. So oxygen always goes to anode and hydrogen goes to cathode. That means because hydrogen is the positive, so it goes to cathode. Because sodium is positive, it goes to cathode. Clear? So similarly above, in case of dilute solutions, here also hydrogen, we get hydrogen instead of sodium. That means when the solutions are diluted, we don't get the salts. Clear? Okay. Now, after that, the law which is very useful in the case of electrolysis is the Faraday's law of electrolysis. Mr. Faraday was a scientist who does a lot of work in the field of the electrolysis and derive some derivations and formulas which are very helpful in producing some relationships. So now Faraday was the first scientist who described the quantitative aspect of the electrolysis. That means he was the first man who gives the quantitative aspect of electrolysis. As we earlier from up to till in the lesson we learned that electrolysis similarly definitions etc. we just learned in electrolysis. But the Faraday is the first man who gave the quantitative, that means mathematical aspect of electrolysis. He gave two laws of electrolysis. Okay, the first law, the amount of electricity required for oxidation or reduction depends upon the stoichiometry of electrode reaction. Or we can also say that, it is a tough one, mass of any substance deposited or liberated at any electrode. That means if we dissolve any substance in the aqueous solution and pass the electricity, then when it dissociates into ion, then the mass of the substance which was liberated at any of the electrode is directly proportional to the quantity of electricity passed. How much electricity is passed in between them. For example, how much course is completed by you, it depends upon how much time you spent in studying. Okay, so that's why in the same way Faraday just decoded that mass of any substance which was collected at the electrode is directly proportional to the quantity of electricity passed. So W, that means mass that was deposited. Z is the equivalent. This is known as electrochemical equivalent. This is the proportionality constant and it depends upon IT, electricity passed per unit time, for how much time the electricity is passed. So this relationship W is equal to ZIT is very important and it was the Faraday first law. Clear? Now, here this electrochemical equivalent is defined as, generally sometimes it is asked as what is electrochemical equivalent, just define it. It is the mass of the substance deposited when 1 coulomb electricity is passed through the solution. When we pass 1 coulomb electricity through the solution, we get the electrochemical equivalent. So it is equal to equivalent weight of the substance divided by 96500, and 96,500 is called the Faraday constant, and that was the number. That's why we remember the Faraday. He presents a mathematical calculation. Okay, magic number of Faraday you can say. Now for example, we have a question. 20 gram of chlorine is evolved in 6 hours from hydrogen chloride solution. We want 20 gram of chlorine in 6 hours. And how much electricity we have to give? Now we have the formula equivalent weight over 96500. From that relationship over here you can see Z is equal to equivalent weight upon 96500. Okay, and from here we also have Z is equal to W by IT. So now we can equate both of them. From this formula W is equal to Z IT, we can evaluate Z is equal to W by IT, and from his formula we have equivalent weight of substance over this. So we just equate both of them, W by IT and this. Okay, clear? So now we have to find the current. So we have the formula W into 96500 equivalent weight into time. Clear? Now understand that from where this formula came. Now we put all the things. Now weight here is 20 gram. This is the Faraday number 96500. Okay. Now equivalent weight is 36.5. Why? Because chlorine, hydrogen chloride. Solution is hydrogen chloride. So hydrogen is 1 and chloride is 35.5. So when we add, we find the molecular formula, that is 36.5. Okay, clear? Now time in 6 hours, 6 and 36 hours you have to convert it into seconds. Then after, when you solve, you get the current. That means 2.45 ampere current is passed in order to get the 20 gram of volume. Now this formula is very important. You just list a formula in order to solve the numericals. Now next question we have. This coulomb of electricity on passing through the electrolyte solution deposited this much amount. That means here current is given, weight of the metal is given, atomic mass is given. Now we have to find the charge. Okay. So now weight is 2.997. This is equivalent constant. Now here the E we take out here, I into T. So I is time is not given, so we can take it as 1. So from here, listen, this is the equivalent weight. And charge on the metal cation, we can easily find the valency. So now atomic weight is, atomic mass is given 106.4. We have to divide by equivalent weight. And when we divide, we get the valency. So this formula is also very important. How will we find the valency? That means when we multiply equivalent weight with the valency, we get the atomic weight. Okay. So both these two formulas are very important, very helpful in understanding the Faraday's law of numericals. Now Faraday's second law, it is just like a statement. When same quantity of electricity is passed through solutions of different electrolytes connected in series, not in parallel, the weight of the substances produced at the electrodes is directly proportional to their equivalent weight. That means weight deposited depends upon the equivalent weight. For example, I have an example. For example, in a class, a teacher take the class and two children, the teacher take the for the same time, the teacher teaches the same lessons, the teacher told the same thing, okay, but the different students get different marks. How it happens? Because of their IQ. So similarly over here, weight of the deposited depends upon the equivalent weight of them. Okay, clear? Now we have here the numerical also. There are two, AgNO3 and CuSO4. If silver is deposited 1.08 and we have to find the copper, we simply use this. But here we put the equivalent weight. So equivalent weight of copper is 63.5 by 2. Okay, we have to divide by 2. So from here we put all these things and find the answer. Okay.